And welcome to Technical Utkranti. And today we'll be looking into the fourth question on binary search, which is finding the pivot of a sorted and rotated array. What is this? We'll come to see shortly. But before that, let's have a look at the thought for the day. So these are the videos that we have done in binary search. Let's move on. So you're given an array which is sorted and rotated. We need to find the pivot element around which the array is rotated. So as you can see that this array was initially sorted and then rotated. So 0, which is given to us as the the element which is the pivot, okay, we need to find its index, or we can say that we need to search 0 in this element and return the index of it. So this is the algorithm of binary search in order to find the index of that particular target element. So let's try to understand the algorithm on the left and the example on the right. So I have taken this same array 4, 5, 6, 7, 0, 1, 2, and above I have written the indices of each of these elements. Now let's go by the algorithm and try to understand how this algorithm works on this particular data set. We start with making low to 0 and high to 6. Low is 0, high is 6. Alright. Then we see if until low is less than equal to high, continue with this. Alright. What is this? First we calculate mid. Mid comes out to be 3. And then we compare if the target value is equal to nums of mid. So whatever mid that we have calculated at that index, if the value at that index is equal to the target, then just return the index. So what is nums of mid? Nums of mid is 7 and target is 0. Target is 0. Are these equal? No. All right. Then we come here. We see that if nums of low is less than equal to nums of mid, what is this check doing? Nums of low is 4. Low is 0, nums of low is 4, and nums of mid is 7. So if this check is there, then we have to do the following. But let's first understand what this check is for. As we can see, if the array was totally sorted, then the numbers would have increased like this, right? With the index. Okay, like this. But as we can see that now a part of the array is like this, then a part of the array is like this. So the number increases like 4, 5, 6, 7, and then 0, 1, 2. All right, like this. Like this. All right. And and at the target value here, we have this inflection point, we can say, right? Where the values suddenly drop at this point. So whenever nums of low is less than equal to nums of mid, nums of low is less than equal to nums of mid, it suggests that we are either in this area or we are either in this area, right? So this is the check for this. And if that is not the case, then it means that nums of low is greater than nums of mid, which means that mid has been computed somewhere here and low is coming over here. So for such a case, the process in the else part. Okay, I hope this was clear. But in our case, nums of low, which is 4, is less than nums of mid, which is 7. So we are in this region as of now. Now what we'll see is nums of low is less than equal to target. Nums of low is 4 and target is 0. No, it is not less. 4 is not less than 0. So what we see, target is not between low and mid. Target is between mid and high, right? So what we do low is equal to mid plus 1 to make a search space the right half. So low becomes mid plus 1, which is 4, high is 6, mid becomes 5. All right. So mid becomes 5, this element, low becomes 4, this element, and high is 6, this element. All right. We'll again see that is mid index value is equal to target? No. This is 1. Target is 0. No. Is low less than equal to mid? Yes, we are in this half only, where lower element is smaller than the higher element. Okay, fine. Is nums of low less than equal to target? Nums of low, yes, nums of low, which is 0, this is equal to or less than equal to target. Yes, this is true. Which means that this is mid, this is low, and this is high. We can visually also see that the number is in the left half, right? So we make high is equal to mid minus 1. High is equals to mid minus 1 is 4, and we get mid also 4. So both low, high, and mid comes out to be this value. And we see that if target is equal to nums of mid, then we get, then we return the mid index, right? So we have seen when the case when nums of low is less than equal to nums of mid. But when that is not the case, then we are in this region. We are in somewhere this region where low is here, mid is here, and high is somewhere here. Correct? So what they are checking in this case, if the target if the target is between mid and high, so what can happen? Target can be between this half, or target can be between this half, right? So if the target is in this half, that is what this check is about. This if is about this only, that if the target is between the mid and the high, then what they are doing, they will make this as the search space. All right, and otherwise they will make this as the search space and continue. All right, so I hope you understood the correlation between algorithm and example. And let's see by submitting what happens. So I've submitted it, and yes, our answer is accepted. So I hope you would have definitely liked the problem, the explanation of solution, and the code. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.